Hello everyone. So to introduce you to the dynamic programming approach, there is one more algorithm called as change making algorithm. So here the change making algorithm would be like, assume that you are in a shop and you purchased something and the shopkeeper has to give you the change of amount 6 rupees. Okay, and out of 6 rupees he can, like, he has 1 rupee coins with him, he has 3 rupees coins with him, and he has 4 rupees coins with him. Okay, so you want to get back 6 rupees using least number of coins. Okay, so he has a collection of 1 rupee, 3 rupees and 4 rupees, but you want the change with the least number of coins. This is one challenge. Okay, so you can get the change in two different ways. One way is, so total 611 rupees coins can be given to you, and the other way is 3 plus 3, I mean only 2 coins. So you can see here, so rather than having 611 rupees coins, the better approach is having only 2 coins, having 3 plus 3 coins. Okay, so how do you solve such problems is the question. Okay, so now for that, what we should do is to trace the given change making algorithm step by step. Let us consider a provided example in the textbook. See, the input amount is 6. Okay, and denominations is nothing but out of this set you are supposed to get value 6. Okay, so this is the final amount. I mean, you want to get the change of 6 rupees. How do you get the 6 rupees? By using this subset of values that we call it as denominations. Either you can have 611 rupees coin, or else you can get two coins of 3 rupees, like that. So which combination is better? Okay, so which combination? I mean basically to improve the performance of the algorithm. Okay, so we should find out that using the least number of coins we should make this amount. Least number of coins, if we take 3 plus 3, that is the least number of coin out of this collection we get, because you should take 1 rupees 1 rupee coins, which is equal to 6 1 rupees coins to be taken. That is not a better approach. If you take 3 rupees, then 3 plus 3 is equal to 6. That is, only using 2 coins you can make up the change. And if you take 4 rupees, 4 plus 1 is equal to 5, 4 plus 3 is equal to 12. It is not a better approach. So that is the problem, and we are supposed to find it out now. So here is the logic behind that. We take an array first, and this array value can be started with basically 1 to 6, because if 0 is nothing but there is no I mean there is no amount, you need not to have to find the change. So initially we assume that f of 0 is 0. Okay, which means that if there is no amount, no necessity of collecting the change, no, that's it. And all other values are set to infinity, because we want to find out the minimum value, no, that's why we set the other values to infinity. So we should trace all the values starting from 1 coin to 6. Okay, like this we trace. This is how we are supposed to trace. So we take a variable called as I, and I'm going to initialize it to 1 because it starts from 1 to 6. And I'm going to take one more temporary variable. As I said earlier, this is required because we want to find out the minimum value. No, that's why we are taking the large number, that is infinity. And I'm going to take one more variable called as j, which will be initially initialized to 1. Okay, so now this is the procedure. So now I should find out d of 1. So d of nothing but they have given the denominations, no, that is called as d of 1. So let me erase this. See, d of 1 value, yeah, d of 1 is nothing but denominations. Actually we have 3 denominations. First is 1, and second value is 3, and third value is 4, I think 4. Okay, so denominations, d is an array. Okay, I mean now we general, let us make d value starting with index value 1 for computing, to make it easy, that's it. Okay, So let us take array value starting with the index value 1, 2 and 3. Okay. So d of 1 is 1. Okay. Now for every time we are supposed to compare this. Okay. This is I value. Okay. J I value and this is d of j value. Okay. So you are comparing I value with d of j value every time. Initially we take the first denomination, that is 1, that is being compared with I value. So 1, is it greater than or equal to 1? Yes, condition is evaluated to true. If true, let us update the value of temp. So temp is equal to, we are finding out the minimum coin. So f of, this is I minus dj. I is 1, dj is nothing but d of 1 is 1. 1 minus 1 is f of 0. Okay, so you can see here f of 0, the base case of this is 0. So 0 comma infinity. Okay, here you can see 0 comma infinity. We should find out the minimum value out of this. The minimum is 0. Okay, so now, which means that in this iteration we cannot able to choose any of the coins. Okay, because I value is equal to 1. No, if it is equal to 1 we cannot able to pick anything at 0. Okay, so now let us calculate for this one. Okay, for f of 1. So f of 1 can be calculated by using the previous value of temp plus 1, which is equal to, previous value of temp was 0. So 0 plus 1 is equal to 1. So f1 value has been updated to 1. Okay. So now let us go to the next iteration. In the second iteration, I value is equal to 2 and j value is equal to, is still equal to 1, and you can check the denomination value like this. So d of 1, again see here, j is equal to 1. No, d of j is equal to 1. Okay, so now compare. 2 is greater than or equal to 1. Condition is evaluated to true. If true, update the value of temp. Okay, you should find out the minimum value. So minimum value here is f of 2 minus 1. 2 minus 1 is f of 1. F of 1 value is 1. So that we have written here. 1 comma infinity is equal to 1. Minimum of 1 and infinity is equal to 1. So update f2 now. Okay, by taking the previous value we should update the value of f2. So temp, updated value of temp was 1. So 1 plus 1 is equal to 2. So f2 is now equal to 2. Okay, so what we are trying to tell is that, see, when you have I is 1, which means that you can only take one coin, that's it. Okay, when I is 1, you can only take only one coin. So if I is equal to 2 also, we can take only one coin. Okay, so if I is equal to 2 also, we can only take one coin. Let us trace for the next iteration. So now I jumped into the last iteration. So I is 5 and temp is infinity, j is 1. So d of 1 is nothing but d of j is equal to 1. So 5 is greater than or equal to 1. Condition is evaluated to true here. So update value of temp. So the temp value is 5 minus 1 is equal to 4. So the previous value of 4 is 1. So it is updated to 1, like that. Okay. So after performing this, so let me show the simple way of calculations. See, so if you have f of 1, see, when I is 1, that is equal to f of 1. Okay, so let me write f of 1, which is equal to f of 1 minus 1, okay, plus 1. F of 1 minus 1 is f of 0. F of 0 value is 0 plus 1 is equal to 1. Okay, you can see here f of 1 value is equal to 1. Okay, so now when I value is 2, let us remove this. Okay, let us remove everything. When I value is equal to 2, okay, let me take I value when I is equal to 2. So when I is 2, we should calculate f of 2 actually. Okay. So f of 2 is equal to, this can be written as f of, okay, so f of 2 minus 1, f of 2 minus 1 plus 1 is the formula. Okay, so f of 2 minus 1 plus 1 is the formula, which is equal to f of 1 is this, f of 1 is this. What is the f of 1 value? 1. So 1 plus 1 is equal to 1 plus 1 is equal to 2. So f of 2, see, look at this, f of 2 is equal to 2. Okay, we updated. Now let us take the next iteration when I value is equal to 3. Okay, let us take the next iteration when I value is equal to 3. Okay, now we are tracing for I value is equal to 3. When I value is equal to 3, so again I value is now equal to 3, no? So here you should observe one thing. When I is 3, when I value is 3, okay, so when I value is 3, so you should find out how many denominations which is less than 3. Okay, so as I said earlier, we have 3 values in the denominations, that is 1, 3 and 4. So 1 is less than 3, you should be taking that into consideration. Okay, so based on this, we should look at the denomination values. In the denominations, we have 3 values, that is 1, 3 and 4. So since 1 is less than 3, you should consider 1 and 3 now for calculations, which means that f of 3 minus 1 should be calculated. Okay, f of 3 minus 1 is equal to f of 2. Okay, f of 3 minus 1 is simply equal to f of 2. Okay, f of 2 plus 1. Okay, so here you can see f of 2 is 2. Okay, 2 plus 1 is equal to 3. 2 plus 1 is equal to 3. So again you are supposed to calculate for f of 3 minus 3. f of 3 minus 3. Okay, so f of 3 minus 3 is simply equal to f of 0, no? So what is f of 0? So f of 0, f of 0 plus 1 you are supposed to compute. Okay, so f of 0 is 0. So 0 plus 0, 0 plus 1 is 1. So that should be updated over here. So now among these, which is the minimum value? 1 as the minimum value, and that you will be taking into consideration. That's it. Which means that, see, you can look at this table. F of 3 value, f of 3 value, which is simply equal to 1. Okay, f of 3 means this, which is simply equal to 1, because out of this we should take the minimum value, this one. Okay, that's how we calculate. And let us calculate for this one. When I value is equal to 4, how many number of coins we get while selecting, when selecting I value is equal to 4. Okay, now when I value is 4, which means that go to the denominations value. In the denominations we have 3 values now, as I said earlier, that is 1, 3 and 4. Now value of I is equal to, so value of I is equal to 4. So which means that all the denominations which are less than or equal to 4 should be taken into consideration. Okay, which means that we should calculate 4 minus 1. 4 minus 1 is f of 3. Okay, so 4 minus 1 is f of 3, we should calculate what is f of 3 plus 1 is equal to, and also 4 minus 3 should be calculated, because under denominations we have three values 1, 3 and 4. All of them are less than or equal to 4. That's why we should take all the values into consideration. So f of 4 minus 3 is equal to 1, which means that f of 1 plus 1 should be calculated, and also we should calculate 4 minus 4. Okay, so we will be calculating 4 minus 4. So 4 minus 4 is equal to f of 0. F of 0. So f of 0 plus 1. Okay. So now let us calculate f of 3. So f of 3 is this. F of 3 value is 1. So which is equal to 1. So f of 1 value, here we have f of 1 value is equal to 1. So which is equal to 1. 1 f of 3 is 1, no? 1 plus 1 is 2. Sorry, 1 plus 1 is 2. Okay. So here also f of 1 value is 1, 1 plus 1 is 2. Okay. So here also f of 0. So f of 0 is 0 plus 1 is equal to 1. So which is the minimum value out of this? Out of these three, which is the minimum value? 0 plus 1 as the minimum value. So hence f of 4 is equal to 1 has been updated here. Okay. So in the same way, we should calculate for f of 5, we should calculate for f of 6. At the end, we are getting 2, means 2 for amount 6, the minimum number of coins required is 2 by using the given denominations. Okay. So for coin 5, the minimum number of change required is 2 coins only. Okay. And for change 4, if you want to get change 4, and minimum number of coins required is only 1. And to get change 3, if you want the change for 3, then minimum number of value required is only 1, because in the denominations we have 3, we have 4, and also we have 2, like that. Okay. So to I want to change for rupees 2, then how many number of coins we require? Only 2 number of coins, okay, to get. That is 3 plus 3. That's it. So here is the complete algorithm. So the base case is 0, because when there is no change to be given, then it is simply equal to 0. As I said earlier, I value is starting with index value 1 to n. Okay, and we initialize temp value to infinity, because we want to compare the minimum value. No, that's why we are storing the largest value. J value will be starting at index value 1. Every time we are supposed to compare I value, is it greater than or equal to d of j, this value. If that is true, so we will be calculating the current amount, and also we will be updating the temp value. Okay. So we take the best solution possible out of this. Minimum value will be taken out, and you should move to the next denomination value and then update. You can store the minimum number of coins needed into this array. Okay, and finally you will return minimum number of coins needed. Okay.